In this video, we'll be talking about fork system calls, and first of all, we'll start with some basics, and then we'll see one example. Fork. The fork system call is used to create a process. Usually, the new process is called a child process, and this child process is usually created by another process called a parent process. And child is usually a complete replica of the parent, complete clone of the parent. That means child process has the same code as its parent process, but they usually have different address spaces and they run independently. Now we got two processes. One process is the parent process and another one is the child process. So both will start executing just at the line following the fork system call. And each process in the system, that means no matter how many processes are running in a system, each process will have a unique PID. So the parent process had one PID when it first started its execution, and then when child process is created, it also gets a new PID. So we have two PID. One PID is for the parent and another PID for the child. Now fork actually returns, the fork system call actually returns two values. It returns two values, one value to the child process and another value it returns to the parent process. The parent actually receives the child's actual PID, but the child process itself, it only returns 0. Okay, and the fork system call might also fail. So if fork system call fails, then it will return a negative value. Now let's see an example where we will see how fork system call actually gets executed and how different block of codes can be executed by parent process and by the child process. Okay, so we have one program, and as you can see that so this program means a process, right? So we have process A, and also assume that this process has PID, let's say 33 for our convenience. Okay, so this process was running, and then so first of all it will print this line before fork on the terminal. Then you see we are making a system call here, and this system call will generate another process, will create another process. So how that process will look like, see this one. So this is the child process. So let's name it process B, and each time a process gets created, it actually receives a new ID. Let's say the new process ID is 48. Okay, so its PID is 48 and the PID of the original parent process was 33. So when we executed this fork, this clone actually created, and the address space of the process A and the process B are different and they will run independently. Now, so as we can see that fork has a return value. So fork usually returns a value that is being received in this variable PID, and as the original parent code has been regenerated in the child process, because it is the exact replica of the parent, so there will be two PIDs, right? So one PID for the process A and another PID for the process B. So fork system call will basically return two PID values. So it will return 0 for the process B, and it will return the child's PID for the parent. So child's PID was 48, so it will return 48 to the parent process. Now we have if else if block of code. See here, so the parent process and the child process may decide to execute different block of codes, and these PID values will help us to define which block of code will be executed by the parent and which block of code will be executed by the child. So we know that the PID values in the original process will be 48 in this example, and the PID values for the process B, that means for the child process, will be 0. So let's see how different blocks of code will be executed. So in the next line, it will check the next line, but PID equals 0, this condition will not be satisfied for the parent process, because the parent process, as a return value of the fork system call, it received 48. So this condition will not be true. Then it will check if PID greater than 0. Yes, PID is greater than 0 because the PID value was 48. So this block of code will be executed. So here it will print what? It will print parent ID, and there is another system call called get PID. Get PID always returns the PID of the calling process. So as it is a parent process, and it is executing the get PID system call, that means get process ID system call. So it will receive its own ID, and the own ID will be printed here. And we also know that this process A actually received the child's ID into this variable PID. So child's PID can easily be printed just printing the PID value here. Let's say that the fork didn't work well. In that case, this else block of code will be executed, and it will just simply print fork failed. And also please note that this line of code, this printf statement, is actually free from these conditions. That for this line we are not checking if PID equals 0 or if PID greater than 0 or so. So this line of code will be executed by both the parent and also by the child. Let's see what will happen for the child process. So child process will check what is the value of the PID. So the value of the PID is 0. So that means this block of code will be executed, and it will simply print child PID equal %d get PID. We have to keep in mind, whenever a process actually calls this system call get PID, get process ID, the operating system will return the actual process ID for the calling process. So the actual process ID for this calling process is 48. So 48 will be printed. But please note, this PID is 0 for this process. So what is the difference between then get PID and PID? So PID is the return value of the fork system call. We could use simply other variables x, y, z or whatever. But this return value actually distinguishes if you are within the parent process or if you are within the child process. That is the main reason of using this return value. Okay. Other than that, always remember that get PID function always returns the process ID of the calling function. Now, if we check the else if block will never be executed, because if block was satisfied and it was executed, right? This printf statement will again be executed by both the parent process and the child process, as we have already discussed. So I hope that it makes things clear.